Hello seniors, we are looking at this week's Algebra 2 assignment and we are looking at what is the best way to solve a quadratic formula. We've done a lot of things. We've done factoring, we've used the square root property, and then over this break we've done a lot with quadratic formula. Today, Mr. Church, if I turn it off of eraser, today Mr. Church has outlined this is how you decide what's the best one to do. And so he says, set it equal to 0, meaning put it in standard form, ax squared plus bx plus c equals 0. Then this point I think is very, very important. Number 2, if b is missing, use square root property. Does it factor quickly? Remember, there are 2 ways to factor. There is just pulling out a GCF, and there is the method where we multiply a times c, see which one adds up to b. The standard factoring that we've done, which takes a good bit of time. And if it does not factor easily, then jump into quadratic formula. He then offers you many, many examples over the following pages. I'm not going to read through all of those for you. I believe that you are capable of reading them and moving through them and using them as assistants. So the first thing we're going to do is we are going to go ahead and get started on the practice problems. And again, I will not do all of them for you, but what we are going to do is we are going to first go through together as a group and label them. So if you look at number 1, you have ax squared plus bx plus c, except that you'll notice you are missing the c, okay? Which means for this one, you are either going to factor or use quadratic formula. On number 2, we have ax squared, where a is 1, plus c. b is missing, so you are going to use square root on number 2. Number 3 is, again, there's a 1 there, ax squared plus bx plus c. It has all of the required parts, which means either you are going to factor or use quadratic formula. Number 4, I like to mix up my colors. Number 4, there's that 1 there. So you've got ax squared plus bx plus c, which means you are going to factor or use quadratic formula. And then number 5, let me switch out that orange, it's not very fun. Number 5, again, ax squared plus bx plus c. So either factor or quadratic. Scroll down here to number 6. Number 6 is not in the correct order. And unfortunately, number 6 is also very hard to see underneath my pens. I'm going to turn my pen off again here real quick. X squared equals 60. I'm going to move number 6. So number 6 says x squared equals 60. We want to get that into standard formula. We have to move the 60 to both sides. So it is x squared minus 60 equals 0. And that has ax squared plus c, which means that on number 6, you are going to use the square root principle. All right, now let's actually practice solving a couple of these. Let's look at, let's do odds. Actually, no, we won't do odds or evens, because if I do evens, then I'll do all the square roots. And if I do odds, I won't do any of them. So we'll just sort of pick and choose. Okay, so number 1, I have 7x squared minus 4x plus c. Factoring, we have 2 choices on factoring. We can pull out a GCF, or we can do the standard little T-chart where we do a times c and b. Well, c does not exist in this case, which means that we can't plug c into the quadratic formula, and we can't plug c into that chart. So our best solution is to look at GCF. What do both of these things have that I can take out? Hopefully you said x, because you are right. They both have an x. So I'm going to pull an x out. 2 x's, take away 1. I'm left with 7x. And then my x on top and bottom cancels out. Minus 4 equals 0. Then you're going to solve it by taking the front and setting it equal to 0, and the back and setting it equal to 0, which means you have to actually solve this one. And I'm going to keep working sideways so I don't take up any space from my other ones. So I'm going to add 4 to both sides. So 7x equals 4. Divide by 7. X is 0 or 4/7. And that is your answer for number 1. Okay, let's look at number 4, and then we'll do number 6 as a square root, and you will have done a little bit of everything. Okay, number 4. I have a x squared plus bx plus c. It's a nice standard formula. I know I'm either going to factor or use quadratic formula. So let's try factoring. We are going to start with a times c, and we're going to see if that will add up to b. So a is 1, c is 3, so 3 times 1, that guy's 3. B is also 3. What are our multiples of 3? 3 and 1. When I add those together, I get 4. Those are my only multiples of 3. So this does not factor well, which means we're going to use quadratic formula, which hopefully you remember is negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to solve that over here because I have little space. Okay, so b is 3, so negative 3 plus or minus the square root of 3 squared minus 4 times a times c all over 2 times a. Then you need to clean that up. So you get negative 3 plus or minus the square root of 9 minus 12 all over 2. Okay, so we're going to keep going on that. 9 minus 12 is negative 3. So I get negative 3 plus or minus the square root of negative 3 over 2. Cannot have a negative under a radical. So remember that this guy right here turns into the square root of 3 times the square root of negative 1. And hopefully we all remember that the square root of negative 1 is I. It's the imaginary unit. So your final answer on this becomes negative 3 plus or minus radical 3i all over 2. That is your final kind of ugly answer for that one. All right, let's look at number 6, and I apologize, I'm going to have to work this direction on number 6 because this is the last page and I cannot scroll down. Okay, so we have number 6 set up as x squared minus 60 equals 0. Here's the thing about that. It doesn't actually work in square root formula that way. We actually have to put the 60 back the way it was. So x squared equals 60. We are going to take the square root of both sides. 60 is not a perfect square, so you're going to get a radical answer, and that is okay. X squared is a perfect square, so this guy cleans up to x. Square root of 60. What is the perfect square that is inside of 60? If you don't know, grab your calculator, but let's look at our perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49. That's all the higher you need to go because none of them have a, none of them are smaller. Those are all smaller, rather. Those are all smaller than 60. And you don't need to go bigger than 60 because obviously 60 does not exist. So you want to look at which one of those goes nicely into 60. 49 obviously doesn't, so you jump down to 36. 36 does not, so you take 60 and you divide by 25. That also does not work. Take 60, divide by 16. Still gives you a fraction. 60 divided by 9 gives you a fraction. 60 divided by 4. There it is. 4 is the biggest square root or biggest perfect square that goes into 60. So your 60 breaks down into the square root of 4 times the square root of 15. That is not your final answer. What is the square root of 4? X equals 2 radical 15. That is your final answer to number 6. So that means you on your own need to do number 5, number 3, and number 2. And remember on number 2, you want this to look like x squared equals negative 16. Do not forget, that guy is going to be a problem child because the square root of a negative number will always be imaginary. Okay? Good luck. If you have questions, you know where to find me. Bye-bye.